In this demo, we will show how to configure the ModBUS communicator to handle communication between an industrial device running ModBUS RTU and an industrial network, in this case ModBUS TCP. We will handle the configuration in the ModBUS Configuration Manager software, which can be downloaded free of charge from ModBUS.com. To illustrate how data is transferred between ModBUS RTU and ModBUS TCP, I am using a ModBUS RTU simulator called ModSim32 on the slave side, and a ModBUS TCP simulator called ModBUS Pol on the master side. Both can be downloaded as shareware from the web. But we'll start with the ModBUS Configuration Manager in the middle. To create a new configuration, I click the New button and start adjusting my configuration. First, I have a look on the controlling network or fieldbus side. I know that the IP address for my ModBUS TCP network is 192.168.0.5, so I specify this. The rest of the default settings for the controlling network are OK for my configuration. The fieldbus type is Ethernet IP, which also includes support for ModBUS TCP. If I'm using a communicator with the article number AB7007 or AB7034, I choose Ethernet IP. If I'm using the newer communicator with the article number AB7028, I use the dedicated choice for ModBUS TCP. I now turn to the sub-network side, which is the slave device running ModBUS RTU. Here I change the baud rate to 19,200, which is the default setting for ModBUS RTU. The rest of the settings here are OK for my configuration. On the sub-network side, I rename my first node to Node 1. This is my slave device. Under this node, I will set up how I want the data to flow to the device and back to the communicator. First, I need to decide where to put the data that I read from the slave. To do this, I right-click and select Add Command. I choose Read Input Registers since I want to read from the slave. In the query, I check that the starting address is 0 and then select the quantity of input registers. This specifies how many registers I want to send in the query to the device. I set this value to 10. The value is automatically changed to the correct hexadecimal value. I then turn to the response. Since I sent 10 registers to the slave and each register includes 2 bytes, I will receive 20 bytes back from the slave. I also change my input registers to say that it is a data length of 20 bytes and that I want this to be placed in data location 0. I now go back to my Node 1 in order to set up a command to write to the slave. Just as before, I right-click and choose Add Command. This time I select Write Multiple Registers in order to write to the slave. I open up my query and make sure that the starting address is 0. Also here, I set the quantity of registers to 10, which adds up to a byte count of 20. Consequently, I also need to change the registers value. I set the data length to 20 and the data location to 0200, which is where the write area of the memory starts. Moving on to the response, I double-check that the starting address is 0 and the quantity of registers is 10. I am now finished with my configuration. Since I am already connected to the communicator, I click Download to download my configuration to the communicator. I can select a name and password for this configuration, but choose not to do so at this time. This concludes the configuration, and I can move on to check that it is working properly. I start by looking at my master simulator for ModBUS TCP. I have 2 windows open here, one for reading from the network and one for writing to the network. In the window where I see the reading values, I press F8 on my keyboard to check the read definition. Here I set up a ModBUS TCP read command. I can see that we are reading from slave ID 1. The ModBUS command is read input registers, the register start address is 0 and the number of registers is 10. If I look at my write definition, I can see that this is OK as well. I can now double-click on a register and change the value to, let's say, 12,400. I click Send and then turn to my slave simulator, where I can see that the value 12,400 has been correctly transferred to the first holding register of the slave. I also want to check that the configuration works from the other side, from the slave to the controlling network. I therefore double-click on the first value in the input register of the slave and change this to, let's say, 1100. And I can see that this is automatically transferred to the ModBUS TCP side. Turning back to the Anybus Configuration Manager,